Expecting that you put it where the sun is, it would loosen up to the circle of Jupiter. This enormous, genuinely shaky, and going to explode star produces impacts that are among the best blasts of radio energy in the entire universe, making more energy than a billion suns. Are you set up for what will happen? Betelgeuse, a gigantic red supergiant star and one of the closest stars to Earth, has recently undergone significant dimming, which has drawn attention and sparked mixed reactions worldwide. This dimming has led to speculation among astronomers and the public about its possible consequences. Some scientists believe this extraordinary behavior could be a precursor to a cosmic explosion, a catastrophic event that occurs when a star exhausts its nuclear fuel and collapses under its own weight, leading to a massive explosion. Such an event raises concerns not only among mainstream scientists but also among the general public, as it brings up questions about the potential impact on our planet. Betelgeuse is a distinctive star, easily recognizable in the night sky due to its unique shape and bright luminosity. Also referred to as Alpha Orionis, it holds the title of the brightest and largest star in its constellation. Recent data collected by NASA's Hubble Space Telescope, along with observations from various observatories, indicate that Betelgeuse experienced a massive mass ejection in 2019. This behavior is unusual for a star of its kind and has sparked global interest among astronomers. While coronal mass ejections are common in our own sun, the extraordinary event observed in Betelgeuse adds an intriguing layer to our understanding of stellar life cycles and the dynamics of massive stars. The distance to Betelgeuse remains a topic of debate among astronomers. Some estimates suggest it is farther away, while others indicate it may be as close as 724 light-years from Earth. Determining the exact distances of red supergiant stars like Betelgeuse is a complex challenge due to their enormous size and unique properties. Betelgeuse stands out as one of the brightest stars visible in our night sky, boasting a luminosity many times greater than that of the sun. However, this immense brightness comes at a great cost. Betelgeuse burns its nuclear fuel at an accelerated rate, hastening the inevitable end of its stellar life. Eventually, the star will exhaust its fuel supply, leading to a dramatic collapse under its own gravitational pull, possibly resulting in a cosmic explosion. This explosion could give rise to a neutron star or even a black hole if current astrophysical theories prove correct. This raises an important question. Does Betelgeuse pose a threat to Earth? If a cosmic explosion were to occur just a few hundred light-years away from our planet, the consequences could be devastating. The impact of a supernova can release an unprecedented amount of light, potentially equaling that of an entire galaxy. Even if Betelgeuse is relatively far away, its cosmic explosion could still have significant and widespread effects. Amazingly, since the last major explosion observed in our own galaxy in 1604, humanity has yet to witness such an event up close. However, a remarkable cosmic explosion occurred in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. While that event had massive effects, it posed no direct threat to Earth. Still, it served as a reminder of the scale and potential impact of such cosmic phenomena. The concept of a danger zone surrounding a typical supernova is fascinating and could have serious implications for life on Earth. If a supernova were to occur nearby, it is important to understand that, in the vast cosmic landscape, supernovae are relatively small events compared to gamma-ray bursts, which are far more powerful and pose a different type of threat. Gamma-ray bursts can have devastating effects, capable of destroying biospheres and bombarding planets with lethal radiation. For example, a particular type of massive explosion can lead to the destruction of a planet's ozone layer, leaving it vulnerable to harsh space radiation long after the explosion has occurred. This potential risk was highlighted in a recent study that outlined new possible dangers associated with massive stars that end their lives in such a spectacular manner. When massive stars explode in a supernova, they can reach some of the brightest luminosities known in the universe. In fact, the brightness of a single supernova can surpass the combined luminosity of billions of stars. This raises the question, what would happen if Betelgeuse were to undergo such an explosion? If Betelgeuse were to explode, it would become the second brightest object in our sky after the sun remarkably. Despite the vast distance separating it from us, Betelgeuse, shining brighter than a full moon, would be visible even during daylight hours. The sheer power of the explosion would create a display so astonishing that shadows would be cast even in complete darkness. Such a sight would be both awe-inspiring and terrifying, demonstrating the raw power of cosmic events. While the visible light emitted by a supernova is indeed breathtaking, it is only a small fraction of the total energy produced during such an event. Although high levels of visible light can cause temporary visual impairment, the greater concern lies in the high-energy radiation emitted alongside it. This radiation often takes the form of X-rays and gamma rays, which can have widespread consequences. One of the primary dangers posed by this high-energy radiation is its ability to deplete the ozone layer that protects our planet from harmful solar radiation. Without a strong ozone layer, life on Earth's surface would be exposed to extreme ultraviolet radiation from the sun, potentially leading to mass extinction events. The immediate aftermath of a supernova presents imminent risks, but in the long term, cosmic rays and subatomic particles traveling at nearly light speed would begin to infiltrate the solar system. These cosmic rays can break down ozone layers and coat the Earth's surface with harmful radiation, amplifying the dangers posed by the initial explosion. Moreover, these cosmic rays carry a significant portion of the total energy released by the supernova, and their long-term effects could persist for thousands of years. There is evidence suggesting that such events may have impacted Earth in the past. For example, elevated levels of iron-60, a radioactive isotope produced in supernovae, have been found in ocean sediments and lunar soil. This discovery suggests that Earth may have been affected by supernova explosions in relatively recent geological history, perhaps within the last few million years. Astronomers have previously concluded that there are currently no nearby supernova candidates that pose an immediate threat to life on Earth. However, ongoing research has uncovered new potential dangers associated with certain types of gamma-ray bursts. These gamma-ray bursts can release long-range lethal radiation, which poses a more serious risk to planets like our own. The mechanism behind this involves a star approaching the end of its life while being surrounded by a significant disk of material. When the supernova occurs, a shock wave is generated, striking this disk and causing it to become incredibly hot. This, in turn, releases a massive amount of high-energy X-ray radiation, which can travel vast distances. This high-energy X-ray radiation, traveling across space, has the potential to impact planetary atmospheres, stripping away protective layers like the ozone. If such an event were to occur within a few hundred light-years of Earth, the consequences could be severe, leading to long-term climatic changes and increased exposure to deadly radiation. Scientists have speculated that past mass extinction events on Earth may have been triggered by cosmic phenomena, such as nearby supernovae or gamma-ray bursts. The sudden increase in radiation exposure could have disrupted ecosystems, leading to the collapse of food chains and the extinction of many species. While the probability of a catastrophic supernova explosion affecting Earth in the near future remains low, ongoing studies continue to monitor massive stars like Betelgeuse. Understanding their behavior helps scientists assess potential risks and develop predictive models for future stellar explosions. Recent advancements in space observation technology, such as more powerful telescopes and improved data analysis techniques, allow astronomers to study the life cycle of massive stars with greater accuracy. By closely monitoring Betelgeuse and similar stars, researchers hope to gain deeper insights into the mechanisms behind supernovae and their potential effects on surrounding planetary systems. Despite the concerns surrounding Betelgeuse's eventual explosion, it is important to remember that such events are essential for the evolution of the universe. Supernovae play a crucial role in the creation of heavier elements, dispersing them across space and contributing to the formation of new stars and planetary systems. The elements that make up our own planet, including those found in our bodies, were once forged in the hearts of dying stars. For now, Betelgeuse remains an object of great interest and intrigue. Whether it explodes within our lifetime or continues to shine for thousands of years, its fate will serve as a reminder of the immense power and beauty of the cosmos. As we look up at the night sky, we are witnessing the universe's ongoing story, one filled with destruction, creation, and the relentless march of time. The eventual explosion of Betelgeuse, whenever it occurs, will be a spectacular cosmic event, offering both scientific revelations and a humbling glimpse into the dynamic nature of our universe. Colossal distances through space, the most brilliant X-ray supernovae, can possibly exhaust a planet's ozone layer by as much as half, making conditions that could trigger an elimination event within a range of around 150 light-years. Luckily, no candidate X-ray supernovae have been identified in the immediate vicinity of Earth. However, this research has led to new insights regarding the cosmic habitable zone, the region within galaxies where conditions are suitable for life. These findings suggest that this habitable zone may be subject to additional constraints. Specifically, the outer regions of a galaxy might not have enough star formation activity to produce the elements necessary for the formation of rocky planets. Meanwhile, the inner regions, where stars form and die at a faster rate, present their own risks. Frequent supernova explosions in these regions can illuminate the surrounding space, increasing the hazards for any potential life that might exist there. New research suggests that the inner boundary of the cosmic habitable zone may be farther from the galactic center than previously thought, reshaping our understanding of where life may, in fact, thrive. So, what will the Betelgeuse supernova look like from Earth? While Earth's biosphere will likely remain unaffected, the actual spectacle will be hard to miss. According to experts, Betelgeuse will continue to shine brightly for over 90 days following its explosion, reaching a glow comparable to a fraction of the moon's brightness, several times fainter than a full moon. Essentially, it will appear as a brilliant point in the sky, visible even during the day. Its striking brightness will dazzle anyone who looks up, casting shadows even at night. This extraordinary celestial event will undoubtedly be a source of fascination for people on Earth. As the supernova remains visible to the naked eye for months, its remnants will gradually fade. However, scientists continue to study Betelgeuse to uncover more about the life cycles of massive stars and the processes that lead to their violent ends. Understanding these enormous phenomena is crucial for gaining insights into the evolution of our galaxy and the creation of elements. During a supernova explosion, not only is visible light emitted, but a vast range of heavy elements, such as gold, silver, and uranium, are also forged in the extreme heat and pressure of the blast. This process, known as nucleosynthesis, plays a vital role in enriching the interstellar medium with the building blocks essential for future star and planet formation. Interestingly, the remnants of a supernova, known as a supernova remnant, can become a stellar nursery where new stars are born from the dust and gas ejected during the explosion. This cyclical process highlights the interconnectedness of cosmic events and how the death of one star can lead to the birth of others. Scientists have identified various supernova remnants that are still forming new stars long after the original explosion, showcasing the dynamic nature of the universe. Another fascinating aspect of studying supernovae is their role as cosmic distance markers. Astronomers use Type I supernovae, explosions of white dwarf stars that reach a consistent peak brightness, as standard candles for measuring distances in the universe. This method has significantly contributed to our understanding of cosmic expansion and the discovery of dark energy, a mysterious force driving the acceleration of the universe's growth. Additionally, the study of supernovae provides insights into the potential habitability of exoplanets. Researchers are examining how radiation emitted during these stellar explosions could affect planets orbiting nearby stars, potentially influencing their atmospheres and the viability of life. This research underscores the importance of understanding the environmental conditions that govern life across the universe. The possibility of observing a nearby supernova raises intriguing questions about how society might respond to such cosmic events. Throughout history, supernovae have inspired myths, legends, and artistic expressions. The explosion of a star is not just a scientific phenomenon. It becomes a powerful symbol in human culture, representing transformation, destruction, and rebirth. In many societies, the appearance of bright new stars in the night sky has been interpreted as omens or messages from the cosmos. Furthermore, advancements in technology have revolutionized our ability to detect and study supernovae. Space telescopes equipped with cutting-edge sensors can capture detailed images and spectra of these events, revealing their structure and behavior. Ground-based observatories also play a crucial role in monitoring transient events, allowing astronomers to respond quickly to observations and collect real-time data. The future of supernova research holds exciting possibilities. New telescopes and instruments, such as the James Webb Space Telescope, promise to provide unprecedented insights into the life cycles of stars and the dynamics of their catastrophic deaths. These observations could lead to breakthroughs in our understanding of stellar evolution and the fundamental processes that shape our universe. In summary, the study of Betelgeuse and its impending supernova events serves as a gateway to broader discussions about cosmic evolution, universal recycling, and the impact of these phenomena on life and culture. The examination of such massive stars deepens our appreciation for the complex and often violent processes that govern the universe, illuminating our place within this vast, ever-changing cosmos. Supernovae also play a crucial role in the larger cosmic timeline, marking the end of a star's life and the subsequent formation of new stellar structures. For instance, the remnants left behind can evolve into nebulae, vast clouds of gas and dust that serve as fertile ground for new star formation. These regions can harbor complex chemistry, contributing to the development of organic molecules that are the precursors to life. Additionally, the shock waves produced by supernova explosions can trigger star formation in nearby molecular clouds. This process, known as triggered star formation, demonstrates the interconnectedness of cosmic phenomena and shows how a single explosive event can set off the birth of new stars and planetary systems. This underscores the significance of supernovae, not only as endpoints, but also as catalysts for future cosmic development. In the grand scheme of the universe, supernovae also contribute to the distribution of heavy elements throughout space, enriching the material from which future stars and planets are formed. Ultimately, this process influences the chemical diversity essential for life. This cosmic recycling highlights the importance of understanding supernovae in the broader context of astronomy and the origins of the elements that make up our own planet and life itself.